Next is the design of school building. Everyone wants safe and of course affordable school that function well. That is, they must be respond to three basic needs: the security, identity, and opportunity. Most school building answers students' identity needs. A well-designed school encourage better student performance and make a lasting impression of the community about the importance of education. In the Philippines, in view of the budgetary limitation, these basic needs are taken into account in any renovation of new building plans. Thus, design guidelines have to be considered. So we have this design guidelines, the placement and layout of the school buildings, the school building orientation, layouts, building plan requirements, and design requirements. The following guidelines shall be observed in the design of school building. A school building shall be designed in accordance with its function, needs of its user, and the nature of the environment. In view of scarce resource, a school building shall be conceived for economy in construction, utilization, and maintenance. The design approach shall be straightforward, relying upon simplicity of concept in the context of innovation to reflect order and dignity, ensure flexibility and anticipation of educational change, and achieve instructional stability. We have human dimension, static and dynamic, specifically with reference to Filipino children and youth, shall be the basis for establishing scale. We have aesthetic elements shall be integrated to the overall design, and even given contemporary treatment shall drive uh, shall derive from historical, traditional, and native themes. And we have the use of indigenous and locally produced materials shall be maximized in conjunction with the application of appropriate construction technology. And then we have the provision for mobility, handicap, disabled persons shall be given due consideration in the design of construction of school building and other facilities in accordance with the Batasang Pambansa bilang 344, which is the accessibility law. That is why the school building, there should be a ramp for those who have wheelchairs. Okay, in designing school building consideration, it should consider the ergonomics, the anthropometric, the thermal, comfort, illumination, acoustic, and color. In terms of placement and layouts, a school building shall be properly oriented, for example, properly placed with regard to air current, natural light and heat from the sun, utility of the plant and ground, and most advantageous display. It is directly related to the heat or to the health and comfort of of the pupil, student, and teachers, hence the efficiency of the school plan. And in terms of school building orientation, the orientation of school building located at the coastal areas should be considered the direction of possible storm surge. Impact of storm surge will be less if the shorter side of the building faces the coast instead than its front. The proper orientation of school building aims primarily to minimize direct sunlight inside the classroom and to maximize the entrance of breeze or currents into them. The solar path and the prevailing wind are the two major factors to be considered in orientation of the building. The school building orientation, the proper orientation along solar path. Okay, the solar or sun path refers to the trajectory of sunlight as the Earth rotates on its axis, typically moving from east to west. So uh, the path is not static. It varies slightly with the season, which can influence how sunlight interact with building. For example, during summer solstice, the sun is higher in the sky, while the winter solstice, it appears lower. The season variation is crucial in or for designing buildings that maximize natural light and minimize energy consumption. Now, under the direction of the prevailing wind, the concept of prevailing winds, particularly in the context of school buildings, is essential for creating comfortable and energy efficient learning environment in the Philippines. Prevailing breeze typically blow from the northeast to southwest, okay, specifically during the hot season. Understanding this wind pattern can significantly influence the design and functionality of the school building. Now we have this recommended school building orientation. So it's slanting. Okay. The recommended orientation of school building in the Philippines is crucial for optimizing natural ventilation and minimizing heat gain, particularly given the country's tropical climate. By aligning school structure along with the northeast to east-west axis, building can effectively capture the prevailing breeze that flow from the northeast to southwest, especially during the hot season. This orientation helps to enhance airflow, making classroom cooler and more comfortable for students and teachers, thereby improving the overall learning environment. The Department of Education 2023 additionally properly oriented can reduce reliance on artificial cooling system, promoting energy efficiency and sustainability in school design. Actually, based on my experience here in our school, we follow the orientation on the uh, oriented along with solar path. Okay? Uh, because every morning, kanabitang kuan kay siya. Sulaw kayo sa mga student kay pagsaka sa adlaw, maigo gyud din directly ang ilahang classroom. And then it is blocking the air. That's why in the afternoon class, it's very hot. Though we already have a four uh, kaning wall fan or ceiling fan, it's still not enough because the air inside the classroom is hot. Init ihapon. Ang buga sa electric fan kay init. So the terms of orientation in our classroom is ginablock niya ang hangin katong sa north, east, west. Murang sa lobby, hangin kaayo, but then you go inside the classroom, grabe ka init. Though this is the recommended school building orientation, but I think not all of the school are following this orientation. Now, in terms of layout, the layout of school building and school site refers to the location and arrangement of school building to achieve maximum function, efficiency, and aesthetic effect. As a general rule, the different school buildings shall be laid out according to the functional group. The distance between school buildings shall be such that ventilation is not obscured. Okay? Then, natural illumination is not impeded and sound in one building do not carry into the next building. The suggested minimum distance between buildings are 8 meters between one-story building positioned side by side, and then 10 meters between two-story academic building positioned side by side, and 10 meters between non-academic building. And for a main building facing for the front gate, at least 10 meters distance is suggested. And greater distance than the minimum between school building is desired. Wider distance between buildings allows for adequate free space to be utilized for many school-related activities. And then we have the recommended minimum setbacks of school from the street is about or is 5 meters to minimize intrusive sounds. So para layo-layo siya sa highway para dili saba kaayo sa mga sakyanan. And then the school site development plan must be considered in laying out of the school building. In terms of building plan, There are two types of plans for the design and specification of public elementary and secondary school building. First is we have the standard building plan. This is usually prepared by the architect and engineers in the Department of Education and the DPWH and approved for general use in school throughout the country. And then we also have the special building plan. This is plan designed specifically for a particular school for a special purpose or because of certain unique or peculiar features at the school sites. A special building can plan may originate from the field. It's like special building maybe those areas that is prone for like dool sa dagat. So lahi ang ilahang specification because they have to consider also the high tide or low tide or the prone for tsunami as well. We have the building plan requirements. A school building plan originating from the field. Local government units and private entities shall be submitted to the Physical Facilities and School Engineering Division, Office of the Planning Services, DepEd for review and approval. So these are the requirements. The plan shall be drawn in tracing paper measuring 0.50 by 0.75 meters according to an appropriate scale and shall show the following: perspective and side plan, floor plan, front, rear, right, and left elevation, two section, foundation plan, floor framing if elevated, roof framing plan, ceiling plan, and electrical layout, plumbing layout, and the details. Second requirements is the original copy of the plan on tracing paper together with two sets of white print or blueprint shall be submitted. Then the third is the architectural and structural plan shall be signed by the architect and civil engineers respectively, duly stamped with their dry seal along with the registry number, professional tax receipt, and the tax identification number. The fourth is the structure computation signed by a registered civil engineer and stamped with the dry seal shall be submitted together with the plan for checking. The registry number, professional tax number, and tax identification number of the civil engineer shall also be indicated. And the fifth, we have the plan shall be signed by the school administrator concerned and recommended by the school's division superintendent and the DepEd region director in case of locally designed school building. The design requirement for school building, so windows shall be equal to or at least 10% of the floor area of the room. Window toilets and baths which shall be not less than 1/20th of the floor area of such room or not less than 240 square milliliters. The ceiling height of the room with natural ventilation shall be not less than 2.70 meters measured from the floor to the ceiling, and the room provided with artificial ventilation shall have ceiling height not less than 2.40 meters. The floor construction, all floors shall be so framed and secured into framework and supporting walls so as to form an integral part of the school building. The type of floor construction used shall provide means to keep the beam and girders from buckling. For roof construction, all roofs shall be framed and tied into the framework and supporting walls so as to form an integral part of the whole building. Dark stops, roof drains, flashing, etc. Shall be provided. Purlins can be made up of angle bars instead of conventional C-purlins, where text screws easily loosen resulting into the detachment of roofs, and the thickness of angle bars serve as knot holding text screws firmly. Purlins are securely welded to steel trusses creating a sturdy roof framework. And for exit door, the classroom should at least two exit doors are required where the number of rooms occupants is over 50. In case of classroom, conference room, exhibit room, gymnasium, school shop, vocational institution, laboratories, auditorium, there shall not be less than 2.10 meter high and 900 millimeter wide. The door shutters shall be swing out and be capable of opening at least 90 degrees so that the clear width of the exit way is not less than 700 millimeter. No door shutter shall exceed 1.20 meters in width. The corridors, every corridor shall not be less than 1.10 meters wide and shall be unobstructed. Stairways serving an occupant load of 50 or less must be 1.10 meters wide. Those serving more than 50 shall not be less than 1.50 meters. The raise of every step shall not exceed 200 meters or milliliters, and the trend shall not be less than 250 millimeters. Handrails shall be provided on each side of every stairways having more than 4 steps. Next is the building risk reduction requirements. The risk reduction refers to the strategic and measurement of implementation to minimize the likelihood and severity of potential losses or damages from various hazards. This concept is essential across multiple sectors including business, the healthcare, and education as it helps protect individuals' assets and communities from adverse effects. In the context of education, risk reduction involves identifying potential risks such as natural disaster, accident, or health emergencies and implementing proactive measures to mitigate these risks. For example, schools may conduct safety drills, improve infrastructure to withstand earthquake, or develop health protocols to manage outbreak. Effective risk reduction not only safeguards the well-being of the student and staff but also ensures the continuity of education activities, thereby enhancing the overall reliance of educational institution. In this topic, we'll discuss the risk reduction requirement for parts of school building and amenities, the hazard resilient approaches, emerging issues and concern, understanding structural issue, immediate remedial measures, building failure mitigation, and miscellaneous requirement. A schedule of detailed engineering activities shall include the following: survey. A survey involves measuring and mapping the land where the school will be built. The process helps determine the topography, boundaries, and any existing structures on the site. Accurate survey are essential for planning the layout of school and ensuring that the building complies with local regulation. And then we have the site investigation. The site investigation is the process of assigning a physical environmental condition of the proposed school site, including examining soil quality, drainage pattern, and the potential hazards such as flooding or landslide. Understanding this condition is vital for making informed decisions about construction methods and materials. Then we have the foundation investigation. The foundation investigation focuses on the determining an appropriate type of foundation of the school building based on soil characteristic and load-bearing capacity. So this step is crucial to ensure the stability and safety of structures as well as the design foundation can prevent future structures issues. Then we have soil and material investigation. The investigation involves analyzing the soil and materials available on site to determine their suitability for constructions. It helps identify the best materials for building and ensures that the soil can support the weight of the structures. This activity is essential for preventing problems like settling or shifting in the future. And then we have the preparation of design. In preparation of design, this involves creating architectural plan and specification of the school building. This includes the layout of the classroom, administrative offices, and other facilities. A well thought out design considers factors such as functionality, aesthetic, and compliance with safety standard. Then they also have preparation of specification. The specification details of materials, the workmanship, and the quality standard required for this construction and the building. These documents serve as the guide for contractors and ensures that the project meets the desired quality and safety standard. Then, uh, one also is the preparation of quantity and cost estimate. Of course, there should be a budget. This activity involves calculating the quantities of materials needed for construction and estimating the overall cost of the project. Accurate estimates are crucial for budgeting and securing funding of the school building. And then preparation of program for work. The program of work outline the timeline. Okay? So kung kano sa mahuman ang building or the project. This helps ensure that the project stays on schedule and allow the efficient resource allocation. Then, the preparation of proposed construction schedule. This schedule provides a detailed timeline of the construction process, including the start and dates of each phases. It also includes estimated cash flow to manage financial resources effectively, ensuring that the funds are available when needed throughout the project. Then we also have the preparation of site or right-of-ways plan, including schedule of acquisition. This involved creating a plan that outlined the use of land for the school and any necessary land acquisition. It ensures that the school has required space for construction and compiled with local zoning law. And preparation of utility relocation plan. If existing utilities like water, electricity, and gas lines are in the way of the new school building, a utility relocation plan is developed. This plan outlines how and when these utilities will be moved to avoid disruptions during constructions. And we also have the prepare and submission of design report. The design report summarizes all design decisions, including the rationale behind them. The document is submitted to relevant authorities for approval, ensuring the project meets all regulation requirements. And environmental impact statement for major project. For larger school building project, an environmental impact statement may be required. This document assess the potential environmental effect of the construction and outline measures to mitigate any negative impact. And lastly is the preparation of bid or tender document. Finally, bid or tender document are prepared to invite contractors to submit proposal for the construction work. These documents include project specification, timelines, and evaluation criteria, ensuring a transparent and competitive bidding process. The risk reduction requirement for parts of school building and amenities for main gate or the entrance should be located on secondary road, swing in into the school property. So the gate ang iyang portahan dili pagawas. Okay? And separate services for pupils and guests. Main entrance shall be provide enough clearance for fire trucks and medical vehicles. For electrical features, require protective covering for all wirings and fixtures. So supposedly all the wiring should have a protective covering, but as you observe, in our school we don't have these features. Install a fire alarm system that is affordable. Provide environmental friendly fire extinguisher. Report any defective electrical wirings and fixtures to expert. Hang curtains in the classroom away from the wall mounted fans. And then stairs and handrails. Distance between railings shall not be more than 100 millimeter or 4 inches. For abrupt change in floor elevation, provide ramp to avoid freak accidents and avoid smooth or polished step surfaces and provide non-slip nosing. So, dili dapat ligyas ang stairs. And windows shall be provided with security grills and emergency exit. Doors and exit. Classroom shall always be provided with 2 swing outdoors at the class at the slides of the classroom. And the walls shall be smooth finish to prevent injury to highly active, playful area mobility, mobile primary grade pupils. We have the hazard resilient approach. So the Philippines is prone in various natural disasters like typhoon, floods, and earthquakes, which can damage school building and consume a significant portion of Department of Education's budget. Instead of using funds for repair, money could be allocated to build new school. To address this issue, initiatives are being developed to reduce the impact of this hazard through hazard mitigation planning and disaster risk reduction program. Mitigation involves steps taking steps to lessen the vulnerability of the school to nature and man-made hazard, aiming to minimize the loss of life and of course of property. This process starts with a risk assessment which identifies potential hazard and their impact on school. Understanding this risk help in prioritizing the implementation of appropriate mitigation measures. Key principles include the cost effectiveness, the multi-hazard approach, and the design disaster risk building. In cost effectiveness, implementing mitigation measure before a disaster is more economical than retrofitting after damage occur. And multi-hazard approach is a risk reduction technique should address multiple hazards simultaneously to maximize effective and efficiently. So it can multiple hazards, so it could be a earthquake prone or flood prone types of building. So it will not just address one disaster but multiple uh, disasters perhaps. And then designing disaster resilient building. Experts recommend incorporating disaster resistant design from the earliest stage of planning to ensure building can withstand hazard. So from the planning pa lang yun dapat sa building dapat i-consider na ni ang mga disasters. So appeal na siya sa planning. So the guidelines suggested various techniques to mitigate the effect of natural hazard on school building. By considering these multiple hazards guidelines, school in the Philippines can better protect lives and property from damage caused by natural disaster. So we have here the earthquake. The building design will be influenced by the level of seismic resistant design. So unsa ka kusog ang earthquake. Structural component, the shear walls, braced frame, moment resisting frame and diagram, base isolation, energy dissipating device such as viscoelastic damper, elastometric damper, and hysteretic loop damper, and bracing of non-structured component. I think I don't have much idea of this structural component, but I think these are the recommended for a earthquake resistant type of building. And then we also have typical cyclones and tornadoes. The key strategy to protecting a building from high wind caused by tornadoes, hurricane, and gust front is to maintain the integrity of building envelope, including roof and windows, and to design the structure to withstand the expected lateral and uplift force. Then we also have flood. Flood mitigation is best achieved by hazard avoidance. That is proper site selection away from flood plains. Should buildings be sited in flood-prone location, they should be elevated above expected flood level to reduce the change of flooding and to limit the potential damage of building and the content when it is flooded. So it says the best achieve hazard avoidance. Of course, ipalayo ang classroom or school building sa mga flood area. Okay, but if nanagid sa flood-prone area, at least elevated ang school building. Then rainfalls and wind-driven rains. One of the primary performance required for any building is that it should keep the interior space dry. All roofs and walls must therefore shed rainwater, and design requirements are the same everywhere in this respect. For example, roof drainage design must minimize the possibility of ponding water, and existing building with flat roof must be inspected to provide compliance with the requirements. Now we have the differential settlement or subsidies. Grant subsidies can result from mining, sinkhole, underground fluid withdrawals, hydrocompaction, and organic soil damage or oxidation. Kanabitang mabuslot ang ilalom due to mining, yung mga sinkhole, so malubog ang school building. Subsidies mitigation can best be achieved through careful site selection, including geotechnical study of the site. That is why it's very important to study the soil construction before the soil before building or putting a school. In subsidies prone area, foundation must be appropriate constructed, basement and other below ground projections must be minimized, and utility lines and connection must be stress resistant. When retrofitting structures to be more subsidies resistant, shear walls, geographic and earth reinforcement technique such as dynamic compression and can be used to increase resistance to subsidized damage and to stabilize collapsed soil. Landslide, the technical gravity-driven movement, so landslide. Techniques for reducing landslide and mudslide risk is to reduce or to structures include selecting non-hills or stable slope site, constructing channels, drainage system, retention structures, and defection walls, planting ground cover and soil reinforcement using geothetic materials in avoiding cut and building sites. Then we also have tsunami. A tsunami is a series of course, wave generated from a sudden displacement of sea floor, landslide, and volcanic activities. Although we don't have tsunamis cannot be prevented, the impact of tsunami can be mitigated through urban land planning, community preparedness, timely warning, and effective response. Emerging issues and concern in school building. We have when implementing measures to make school buildings safe, secure, and conducive to learning, there are some important issues to consider. We have the hazard mitigation and sustainability. Measures that protect building from hazard can also contribute to long-term sustainability. So, during planning pa lang, gikuan na gyud, gi-implement na gyud ang i-consider na ang mga like for example, no natural disaster. Of course, there is a long-term sustainability of the building, dili siya dali magawa. Then cost of mitigation in retrofits. Incorporating hazard mitigation into existing building can be expensive, especially for building constructed before modern building codes were developed. So dapat sa sugod pa lang gi-incorporate na ang cost for mitigation kay mas expensive siya if the existing building na nato incorporate ang mga measures or for mitigation. Then we have the relevant codes and standard. Building codes and regulation define the minimum requirement for hazard mitigation, but designers should go beyond these minimums to ensure building can adequately withstand the force they're designed for. Special mitigation requirement will be needed for special hazard in certain location. And we have the non-structured element like the windows, parapets, electrical system. This will make over 70% of the school building value. Designers should focus on protecting these elements to extend the building usable life. We have condemned unfinished construction. So those building wherein already condemned or unfinished, there should be a clear mark of off limit to prevent a accident. And then sanitary facilities, drainage canals. The drainage canals should be wide, covered, and have manhole for safety sanitation. Septic tank must be at least 2 meters from the building and 25 meters from any water source to prevent contamination. By considering this, the hazard mitigation sustainability, cost of mitigation retrofits, relevant code and standard, condemned unfinished constructions, and sanitary facilities, school building can be designed and maintained to be safe, secure, and sustainable as possible. Thus, understanding structure issues. Structure failures are common and considered costly to rectify. That is why most structures problem may be avoided by proper design and planning. Structural issue focused more on the concrete structures failure. Concrete structure failure, since concrete is the most commonly used in building construction due to its durability and ease in construction. Moreover, concrete is the most economical choice in building construction. Steel failures is also considered among structure failures, mainly because it is normally used for trusses. The objective of understanding structural issues and problems are to recognize the common structural problem and their causes, to know the immediate solution and structural problem before the recommendation of the structural engineer have been given is considered, and know how to mitigate the eliminate structure problem. So we have here the main structure element of the building. The main element structures are loaded bearing members. Okay, this supports and transfer the load of the structure while remaining equivalent to each other. Then the place where members are connected to each members are what we call joints. Okay, and dead loads are the weight of the permanent element of the building. Live loads are the weights of the temporary elements such as human, chairs, tables, and other movement element. Then the sum total of load supported by the structure member of the particular instant is the total dead load plus the total live load. The live load is in a structure are transmitted to the various load bearing structural member of the ultimate support of the earth. Immediate or direct support of the live load is first provided by horizontal members like the slab, beams, purlins, and trusses. The horizontal member are in turn supported by vertical member like the column, loads, okay, and bearing walls. And finally, the vertical member are supported by foundations of footings which rest on the soil. So we have the footings here. Then the ability of the earth to support the load is called its soil bearing capacity. This varies considerably with a different type of soil. A soil is a given bearing capacity bears a heavy load on a wide foundation of footings than a narrow one. We have common structure problem failures and causes on the concrete preparation and maintenance problem. We have this crazing. It's a pattern of fine cracks that do not penetrate much below the surface and are usually cosmetic problem. They are only visible if kaning mabasa siya. Kaya din nato siya makita. It's very fine line lang ni siya. Then we have plastic shrinkage cracking. When water evaporates much faster than the surface or freshly placed concrete, then it is replaced by bleed water since the concrete surface shrink. So, kani siya, plastic shrinkage cracking. Then we also have drying shrinkage. Almost all concrete is mixed with more water than is needed to hydrate the cement. Much of the remaining water evaporate, causing the concrete to shrink. Murag kulubot-kulubot ang concrete. And then we have thermal crack. This is due to the temperature raise resulting from a heat of hydration of cementation materials. As the interior concrete increase in temperature and expand, the surface concrete may be cooling and contracting. So, nasobrahan ka init. So, mo nang dako kaayo nga crack. And then, of course, corrosion. Corrosion is reinforcing steel and other embedded metal is one of the leading cause of deterioration of concrete. Kanang kalawang. So again, we still have the common structural problem failures and causes. The concrete performance problem of structural concrete foundations. We have the foundation settlement. The foundation settlement is a cracking may be caused by differential settlement of the footings, poor original construction, water, nearby plastic operation, or improper soil preparation. So, nag-crack ang foundation. Okay. Now, we also have other common structure for concrete. Common structure problem for concrete. We have puncture failure. Okay. Puncture failure are failure caused by excessive concentrated loads or point load, improper use of material, or inadequate foundation thickness. Kanang punctured, so natanggal gyud ang kuan foundation, as you can see in the picture. So we also have another common problem structure for concrete. We had wide beam shear failure, maybe due to improper use of material and or inadequate foundation thickness. Kulang ang kabaga sa foundation. So nag-crack ang foundation, as you can see on the picture. Then we also have the bending failure. This is due to improper use of material, inadequate foundation thickness, or inadequate reinforcing bars. So, ganiha kulang siya og kabaga, kani kulangan pod siya og bars. So that is why nagbend siya and nagcrack ang foundation sa concrete. This is also one of the common structure problems in concrete on the slab on base. So we have punching failure due to excessive concentration of loads or points load, improper use of materials, and inadequate slab thickness. We also have the settlement failure. So a slab indicate adequate site preparation such as failure to compact fill in which a slab was poor. So naay dili pantay ang kuan ang iyang ilalom, so mo nang nag-crack siya. Now on a problem on common problem on suspended slab, we have bending failure due to improper use of material, inadequate slab thickness, and or inadequate reinforcing. So kulang iyahang substandard ang gigamit, so nag-curve siya. On suspended slab, there is also a tendency of punching failure. The common structure problem and failure causes still here in concrete. We have the beams. Beams is the refers to a vital load-bearing element that resists vertical load, shear force, and bending movement. So kato bitaw na foundation katong sa ibabaw na mag-connect sa mga foundation walls. That is the beam. So we have bending failure. This is nag-curve ang beam due to inadequate size or inadequate main reinforced bars. We also have common structural problem failures and cause on the columns. So itong mga katindog ng mga kuan connect sa mga beams. So tendency is bending failure, shield failure kanang nabugatan so murag nag-crack ang gilid. Okay, these are due to improper use of materials. And we have the common structural problem and failures and causes for structural steel. Failure due to environmental exposure. So we have bending failure, so nagbend ang steel. Shear failure, nag-crack ang both side. And then we have the buckling failure. These are due to failure due to heat. Heat changes the steel characteristics which lead to deterioration in strength. And then corrosion, so gikalawang. Steel corrodes in contact with water. So the performance and problem structure, so we have this bending, shear, and buckling failures. And we also have this excessive deflection sagging. So daghan na kayo wala na straight ang mga steel. So the immediate remedial measures, if you find those failures in your building construction, is of course, first is do not occupy the building as it is not safe. And then project engineer should initiate a material testing, a comprehensive strength of concrete, a yield strength of steel. So engineers, you may contact engineers to do that. And then immediately the structural engineer should be called on to investigate further. Okay, the background information of the building, the location description, what is composed of, year constructed, project implementer, and then the plan dimension of the building showing the members, member size, and dimension of location of failures of the members, cracking, the sagging, crash, buckling, settlement, etc. as mentioned earlier. And then pictures of failures, so we're able to provide also the pictures of the failure. The geotechnical report where the soil bearing capacity is shown, result of material test, provide and then after that is provide shoring on horizontal members. So and lastly is inject structural epoxy on concrete crack. It is only applied by professionals, of course. So building failure mitigation. Most structural failures are due to failure to comply to the requirements shown in the structural plan and specification. Okay, during planning, it's already been measured, so there is a standard on how to do the school building, but of course there is always a failure. So the reason for this is not complying to the requirements shown in the structural plan and specification. Members, that's like the member size, the reinforcement, the material specification, the soil preparation, and construction methodology. Having good quality construction is the best way to prevent any structural failure. Yes. So the following shall be the basis for implementing structural to mitigate structural failures. This must also be the basis of accepting and rejecting works. So the most updated and official plan and specification must be used. Make sure that these documents have structural engineering signatures and seal. So of course, make sure that all that involved engineer must sign and seal. Then conform with the specification and requirement structural standard and structural notes. Then ensure that the required member size and material strength will be used, and only the accepted standard methodology will be implemented. Should there be any failure in the material strength test or any structural problems encountered during construction, immediate remedial measure must be carried out. The various types of problem with regards to structure can create a danger or, of course, costly situation. To immediately discover and evaluate the structural defect, we should know the major impact of this on safety. One does not have to be a structural engineer like me, hindi ako engineer, to be able to identify where the structural problem are likely to occur and how to recognize them, as makita man gyud if naagi problema. Kay mostly of the building kung naagyod is you can visible man siya, makita man siya. The miscellaneous requirement in the construction of building under plans and specification prepared by the Department of Public Works and Highways and approved by the consulting architect, no change affecting either architectural features nor substitution of material shall be made without the approval of the consulting architect. So once it's already be planned, okay, the specification, so dili na siya dapat mabag-o without the approval of the consulting architect. And under no circumstances shall any plan, whether prepared by the Department of Public Works and Highway or not, be used for any project other than the one originally intended without first securing a written approval of the consulting architect. Okay? So kung if school building prepared by the Department of Education, dapat specific dito ra pud siya nga project himuon, so dili pwede himuon sa lain or i-copy ang same specification sa uban. Then in case of approved standard plan of the Department of Education are used and no change in the approved plan of specification is made, the prior approval of the Department of Public Works and Highways is not necessary.